I would like to start by the paper from Sudan, which is Trials for the Production of Sustainable Concrete in Sudan by Dr. Tahir Al-Sheikh from Sudan University of Science and Technology and Dr. Selma Mahmoud from University of Science and Technology in Sudan. There are two different universities. Even myself, I was confused. So one is Sudan University of Science and Technology, and one is University of Science and Technology. So I hope I'm getting them right because I can't see Dr. Taysir here, who's supposed to be the first paper. Now, Dr. Tahir, are you available to present?
Hello, bro. Assalamu alaikum.
Yes, alaikum assalam. Dr. Tahir, thank you very much. Can you hear us okay?
Okay, yeah, I'm hearing you.
And now we can hear you, but we can't see you, but you can go straight and share your screen. But before that, I would like to say a few words. Thank you very much for your time, and I very much appreciate your efforts. And particularly these days, I can see that happening in Sudan, in Libya. There's another country as well, where there's severe shortage of electricity, power supply.
Yeah.
So despite that, we very much appreciate, and we hope you now have some kind of power to try to present your paper. You're going to talk to us about a very important issue. This is something we are very interested in WAS, and we have a team has done lots of work on this, particularly in the American University in Sharjah. We have people there have done lots of work in terms of green buildings and so on. So without any further ado, Dr. Tahir is an experienced academics. And if you could also introduce Dr. Selma Mahmoud with you, and then start sharing your screen, and we are listening, Doctor.
Okay, thank you, Victor. You hear me? Sorry.
Yes, we can hear you. Yes.
Okay. Hello, how are you? I am Dr. Tahir from Sudan University of Science and Technology, and my colleague, Dr. Salma Yahya Muhammad Mahmoud from University for Science and Technology. We have the group research. Our presentation about the trial of production of sustainable concrete in Sudan. We also know concrete is the most widely consumed material in the building industry. We have a lot of resource in concrete or in material concrete now. We need about to find another resource for concrete because the concrete now have a lot of material. This resource, the demand of it with the time, we can take more time. This study emerged as the result of realizing the need for innovate material and practice in the building industry to preserve the virgin material. We need to search about another material for concrete to be the material sustainable, because the cement or manufacture of cement now have a lot of unfriendly material. We have in our research or scientific research, we have a lot of trials. We have about 9 trials, but now the result for 5 trials. We need to find these trials about behavior on concrete, like workability, like compressive strength, like durability. What happened if we add some of this material to concrete or to workability test, or sorry, to compressive strength test. We have the 5 suggested scenario we explore to possible outcomes. This from the literature review from material we found in Sudan. This is the 5 suggested scenarios. I talk about one scenario and what is the result for other or for the scenario. Scenario number 1 اللي هم 100 recycle aggregate and natural pozzolana replacement of the coarse and cement in concrete mix. In Sudan, there is a lot of demolition of building. This scenario, we find, or we need to find, if add some of this recycled aggregate and some natural pozzolana from Jabal Marra or whatever for this place, how can this increase compressive strength or increase workability or decrease or whatever? This is a scenario. The picture show how can we take the recycle aggregate and a trial number. In this scenario, you have 8 trials. Each trials have the cement, water, fine aggregate, natural aggregate, recycle aggregate, and pozzolana, and some of the results of the properties of the recycle aggregate and natural aggregate we found in the result. If we compare about 8 scenarios in 7 and 28 days for compressive strength, the results show in 100 recycled aggregate and 10%, we found this is the optimum result. If we can in the concrete mix, recycle aggregate, we can use recycled aggregate for mixes and add 10% of the additing for cement. We have the optimum results. And slumped test or workability test for concrete, we have the results. Also, we find the optimum result in about 100 recycle and 10% of pozzolana. This the all result of Islam test in the range of mixed design, about 30 or 60 millimeter to 180 millimeters. Also do some test durability test for the recycle aggregate and natural pozzolana. Also, we found the trial about 100 recycle aggregate and 10% pozzolana. It is the optimum of this recycle. That is the trial number 1. Trial number 2, he talk about steel slag replacing fine aggregate and cement aggregate. He has the 3 stage. Stage number 1, Jiyat factory, south of city Khartoum. We collect the material. Step number 2, we do XRD tests. Was conducted on the BFS samples. Number 3, it was incorporated in the partial substantiation for sand and then cement formed. A standard mix and other 3 were the slag replaced 10 and 5 and 20. 10 and 15 and 20, and weight of sand, and 15 and 25 and 35 of the cement weight. Also, this we found all the workability in using steel slag in replacement of cement. The workability is decreased. Then in the 35%, the workability decrease. Also, the workability in 28 days increase in 35. If we using the steel slag a replacement of sand, the workability you see is the increase in 20%, but the workability is decreased in 20%. This is the scenario number 2. Scenario number 3, alternated sawdust replacing fine aggregate. Scenario number 4, also treated sawdust replacing in cement and aggregate. In this scenario, we have the 7 trials. Trials number 1, untreated sawdust. Trial number 2, unsocket sawdust. Trial number 3, unsocket trials replacement about 10%. Socket sawdust replacement by 10%, 20%. Trial number 6, the treatment change in hydroxide about 10%. And number 7, the treatment of the sawdust change to 20%. The sample of sawdust from the local local furniture market on Khartoum State. Then we collect the sawdust treated, then used in concrete mix, 7 cases. We have the conducted the compressive strengths for 7 trials. We have some positive result for doing this result for treatment for using sawdust replacement for fine aggregate. Scenario number 4, sawdust the partial replacement of cement. We collect the raw sawdust, some sawdust burning, some sawdust ash sieve analysis using sieve analysis, and picture number 4, hard then sawdust concrete mix. This sawdust we use it in the concrete. Then doing the compressive strength and slump tests for 2 mix number 1 or mix number 2. If we look at the result, we find the compressive strength decrease for sawdust. If you are using sawdust about 10%, then increase we using sawdust about, or using percentage of sawdust 20%. The workability or the slump test, of sample using sawdust decrease about 20%. Then if we increase the percentage of sawdust used replacement of cement, the workability also decrease. Better results are achieved when the ash was used in replacement or cement. Slump value are within the design limit for 30 to 60 millimeter, and compressive strength is just as the target value within 20 replacement ratio. Scenario number 5, curry dust in the partial replacement of the sand. Curry dust is sediment of the reduced from the process of treating and treating rocks. This collected from the manufacturing of cement, then using in the concrete mix. Curry dust from Omdurman, Sudan, and we have the 2 locations. We collect the sample from it, or the curry dust from Al-Jabalain, Sudan. We see the variables of the result for compressive strength. In replacement of for sand concrete mix containing 50, 25, and 35 of QD, in replacing cement. 15, 25, 50 were designed and prepared. Then curry waters workability fresh concrete was measured for all mixes and compressive strength. The replacement of the sand by 15 QD in the best result, and for the replacement of the cement about 25. The result confirms that the suitability of recycled aggregate for full replacement of natural coarse aggregate steel slag was the more appropriate in replacing sand than cement when added in the small percentage, not exist 50%. So sawdust need treatment to eliminate the variables or properties. The addition of QD replacement of 50% of sand offered a reasonable workability, but the compressive strength was only approaching the target value. According to these results, it could be inferred that the test option offer reasonable evidence to confirm there is the potentiality for producing green concrete for Sudan. I am told we have the more of these trials. We have about 8 trials, but this research we focus it on 5 trials. My colleague, Dr. Salma, tomorrow we talk about 1 trials of this about metakaolin in Sudan or kaolinite in Sudan. This is the one of the biggest trials we do it in our research. Thank you, Dr. Alam, Prof. Alam.
We very much appreciate, yes, you can stop the screen sharing now.
Okay.
We very much appreciate this, and we are grateful, and I can see that you are doing your very best, because we just received a message from Libya, from Professor Nasir, who has been for the last 2 to 3 days to find a single 1 hour to try to fix his presentation. He couldn't, and he said now he can't join us because of electricity. And I think this really is the issue quite seriously. We have been discussing this across the whole, lots of conferences in London and others. Africa's major developmental problem is electricity. This is being acknowledged by many people. When we come about sustainable development in Africa, all people, myself included, argue that if we can't fix the energy, and particularly the electricity in Africa, and I can tell you a figure, last year, I think I was in Oxford a year ago, and at that time, the figure I look at, the electricity produced by Korea is bigger than the entire African continent. When I said that, people were shocked. One country production of electricity is higher than the entire continent in Africa.
So please remember, if we all help and do a little bit, it will make a big difference.